Thank you very much for taking the time today to view our video. Before we begin, we'd like to take a moment to introduce ourselves. There are many aspects to 9.Connects, but it boils down to the fact that we're a PCB-centric organization. We believe and focus on the PCB due to the fact that it is truly the center point of all electronic design. That's where our expertise lies. We provide services not only in the PCB layout, but in design consulting as well. And during the technical portion of this webinar, you will see this expertise in motion. We are now the exclusive North American instructors for Altium Designer. We host 100 trainings throughout the year across North America, and we are excited to bring these trainings closer to you. In addition to our services, we are also a value-added reseller for a number of PCB-related software companies. And just to note, each company has been presented in past webinars. So if you're interested in them, please contact us or check out our website. And by the way, we provide one-on-one coaching for these tools as well. For more information on our services and past webinars, please contact us. Our information is listed in the description below. Thank you for giving us a moment of your time, and please enjoy the presentation.
The third in a series of DFM, Design for Manufacturing webinars that we've been doing. Today we're going to be focusing on the library aspects of it. And before we get any further over here, just wanted to kind of give you an interesting thought. I thought the library one would probably be the easiest of the three of them, simply due to the fact that library methodology is my focus and area of expertise. And I wanted to create something I'll call the cherry library, the perfect library. And I thought it'd be a breeze to do. And we have done it, and we're more than happy to provide it to you if you ask for it afterwards. But I think at this point, I think it would have probably been easier to actually grow the cherry tree than to actually make the cherry library. We put a lot of time and effort into it, and it's really amazing because the library that we initially started off with for this example is one that's used all the time. It's perfectly good. We've used it in the past. So the fact of the matter is that yes, it's really good to use, but it could use even more in order to make DFM even more effective in our release or in future products as well. So we learned a lot in doing this, and I just want to put that thought out to you. And that's what we want to do here today. So for our syllabus, what we're going to be doing is covering mechanical layers. We get a lot of questions about this. We also want to talk about naming considerations. I basically fought this beast quite a bit when I was putting together a library for another company a couple years ago. Then third, I would like to talk about footprint considerations and go into a little more depth on them. I feel that a lot of times when we talk about libraries, we talk primarily about the symbols, and the footprints are almost secondary to that. But obviously the footprints are really important because it's the physical aspect of the layout design, and if they're not done right, that's when the respins are going to begin. And lastly, there's just a couple of symbol considerations I'd like to give you as well. All right, just some webinar housekeeping as usual. Just due to the number of attendees, we can't open the phone lines. Feel free to ask questions. My colleague Jeff Condon is also on the line. He'll be answering those questions as we go along. Feel free to type them in at any time you want. Do provide some specifics just because he's trying to follow me here in real time, and he wouldn't be able to flip back on slides if you're being too vague about the question. The big thing I want to mention over here is that this is not an Altium training class. I'm not going to show you how to draw footprints. I'm not going to show you how to use aspects of the tool. If you're coming in from another tool or you don't know Altium, it's perfectly fine. We're, again, trying to talk about high-level DFM concepts over here. Reading materials. If you're looking for some reading materials, this list has changed since the last two webinars here. So the IEEE has what's called the standard 315-1975. This is the infamous ANSI standard. Everybody always talks about, well, you got to go back to the ANSI standard. Well, this actually is the ANSI standard here. ANSI itself is not really in the business anymore of actually writing up specifications. They are in the specification business, but they've really turned over the whole writing aspect over to the IEEE and to the IPC as well. So if you want to know about every single electrical symbol that's out there, not just on your printed circuit board, but any electrical symbol that is used in the industry, definitely take a look at this. It's over 400 pages. It is somewhat of a cure for insomnia, but if you ever want to know a symbol, they probably have it in there. For IPC, they have the 2612 and the 2612A. Unfortunately, both of these you do have to purchase, so if you try to look up online, they're not supposed to be out there, and they are very aggressive about trying to get bootleg copies off the internet. When I did purchase them, as a matter of fact, in the PDFs, they actually write my name in the date of purchase and where I purchased it from on every single page. So that's one of those things, one of the safety features, so it just doesn't propagate out there by itself without knowing who did it. So those are the specifications if you want to take a look at them. They're not too expensive. I think when everything's said and done, they're probably about $300 to $400 for all three of them. All right. Unfortunately, we can't cover everything in 1 hour. So as usual, use your contacts from your contact manufacturer, your fab house, your assembly house. Talk to those people. They're more than happy to assist you in these type of things. Talk to the experienced engineers if you got them at your company. And of course, above all, contact us here at 9.connects. We'd be more than happy to discuss these things with you as well. Our service is over here, but the interesting one I wanted to put over here was assist in libraries for DFM. So as I mentioned earlier, we took a really good library, and we had Jeff and a couple other people review this library over here, and we found a lot of things that we could improve it upon. So if you are looking for someone to go through your libraries and make recommendations for better DFM, certainly give us a call. We'll definitely be more than happy to provide that analysis for you. Of course, with any of the other services that we provide as well. Just very quickly, we're also big on design methodology. We do represent solution quadrants. So if you're looking for a library method, come talk to us. We're happy to have that conversation with you. And also, we represent desktop EDA for that ECAD, MCAD interface. And that's all I'm going to do on the marketing side of things. Let's get on to the good stuff over here. So everything I'm going to talk about today are recommendations. And recommendations, these recommendations are going to be tough for one of two reasons. Number one, if you already have a library and you've already got a convention that's set up, especially a naming convention, and you want to change it, obviously that's going to break links, and that's going to cause a lot of grief. So some of these things you may look at and say, yeah, we wish we did it that way, but we can't. We're kind of stuck with the way we've got it, so be it. Some of them may require a great deal of work, and in that particular case, you want to take a look at some of the trade-offs. So for example, the one that's most common to me is the bill of materials. If you're doing a bill of materials by hand and it's taking you a couple of days and it's prone to error, then you may want to spend the time to actually get the parameters into your library. And that may take some time too, but if you can generate a library in 3 to 5 minutes just because that information is already in the library, then you've automated the process. You've removed a lot of the ambiguities because maybe you didn't forget to put something in there that you ought to have put in there. But you'll also speed up the design process as well. So it's a trade-off. And obviously, if you've got 5,000 parts and you like an idea, and you say, wow, this is really good, let's add Courtyards, well, now you've committed yourself to updating 5,000 components. So we understand there's trade-offs, and hopefully there's a thing or two that you can glean from the recommendations that we make here that would benefit you in the long run. So pre-layout considerations, we look at the library as the foundation of PCB design because it really has a huge, profound impact on the future effort. And I'm not talking about just the layout. I'm talking about those things that happen after layout when it's outside of your control. But even within what's in your control, the designer and the part that they choose, if you have a good library, they can make a good decision as to what component they need to put into it. And then the other ones here, I probably should have animated these a little easier here, but the bill of materials. The bill of materials, if you have a good library, it'll be nice and clean. Purchasing can read it. It's all complete. When you're doing the layout, everything is there. It's ready to go. You have a good assurance that when you place a footprint down, you're not taking a guessing game over here. You know that that footprint's going to work. For fabrication, you know that the fabrication process is going to work because the parts in there have been verified. Assembly, same thing. You know that the parts exist because the bill of materials there. The assemblers can see what you're trying to do. You've put enough spacing in there. Also for tests, they can get their probes in there. They can take a look around. It's easy enough for them to find their way through their product, or pardon me, your project, and also for the mechanical as well for fitment purposes. So look at all the things that we impact by just having a library. But take a look at this one as well. So here's just 6 examples of those things that we can produce by having a decent library, and pretty much all the things I just mentioned in the last slide over here. And this isn't the complete list. It all depends on what you're putting in the mechanical layers, which we'll talk about here in just a moment. So speaking of mechanical layers, we get a question all the time about mechanical layers asking, well, what are we supposed to do with them? Is there a standard? So let's kind of take this one by one here. First and foremost, some companies will call them technical layers, and that's kind of just as good a name too, because it's not just mechanical. It's anything that's above and beyond what we'll call copper and related layers. So these are not layers. So mechanical layers are not the copper layers. They're not the solder mask. They're not the solder paste. Actually, I should say solder paste there. That's something I'll fix a little bit later on. But the fact of the matter is that these mechanical layers are above and beyond that. They are really there for you to provide more information, which I'll show on the next slide here. They don't adhere to the DRC. okay, and with the exception of the 3D bodies. So if you're familiar with Altium, you can have a 3D body. You can either draw it yourself, or you can bring in a step file, and those do reside on the mechanical layers, and those actually do adhere to the component clearance rules. Right, and so that's why I give that one exception over here. But generally speaking, you can draw whatever you want onto those layers, and they will not be flagged as an error. It's for information that you need to put that is kept above and beyond the copper information. All right, so what are we doing with these things? Well, it's to convey information to a particular party, and this is a very, very partial list. So if you're using glue dots, well, the assembly folks would like to know that information, so you could use a layer for that. A mechanical layer for that. How about courtyards? Well, tests would certainly like to see those because in the courtyards they have a general feel for where things are. Layout, when you're doing layout, and we'll talk more about courtyards here a little bit later on, but it's very useful for layout as well, and we'll see why as again a couple of slides from now. Dimensions, if you're putting dimensions down, fabrication would certainly like to see that. The mechanical folks will certainly need to see that as well. And also for 3D, the mechanical folks would like to see that simply because of the fitment issues. And there's a bigger list that can go on and on and on. So the ultimate question people ask is, what's the standard? And the answer is there is no standard. And trust me, I spent a lot of times looking for this. I was trying to find the holy grail of standards. And I went onto the Altium forums, and there are really two really good forum postings on this. The first one in 2009 had over 70 responses to it, and it was a general question asked by a fellow. He's considered to be a super user of Altium. His name's Darren Moore, and he's on the forums quite often. And he asked a very generic question of, what do you think a mechanical standard should contain? And we'll look at the list here and or some of the recommendations in a couple of moments here. And there was a lot of responses to it. And then here in July 2014, a second question came up, but they kind of flipped it around saying, well, what are you using? And everybody just copy and pasted what they were using just to give an idea of how they set up their own company. All right, so the conclusions on the forums, and we here at 9.Connects do agree with this conclusion that there were just too many variations to specific needs. So when they were doing it, they counted up to 42 of them, so 42 different layers, and Altium only provides 32 of them. So we're already short on layers, even if we wanted to be this robust with them. And then, of course, even if there was a standard established, as most people pointed out, most companies simply can't comply with it because they already have one. And they're not going to go in and they're not going to change all their projects. And it's going to be kind of difficult to change up all their libraries because unless there's a script to change those layer information, the layer information, that's just going to take a lot of manual effort, and they're just not going to go through that. So if you're interested in some type of mapping concept, do take a look at this idea over here. So Darren did put that up as somewhat of a compromise. And this would be very useful. So if you're in a situation, for example, if you're in a company and you're merging with another group and everybody's trying to get their libraries together, it would be nice to be able to map these mechanical layers rather than dictate to the other group saying you've got to conform to what we've got. And again, that would take a lot of time to do that. Or in our situation or a design house situation, if you're getting things from customers and there happens to be a central database, then at that point in time, again, you have to rely very much on the customer and work with what the customer has, which makes it difficult for us to have a general generic database. So having a mapping feature would be really nice. But that's where I'm going to leave it at with that. Now, interestingly enough, after I said all this thing about no standards and layers, Altium's kind of forced their hand about some of these layers, and that's due to their library. So certain layers have been allocated by Altium. It's probably due to the fact that they do hardware development, or at least they used to do it. I don't know if they still have it or not. But in the last 15 years, they developed the nanoboards. They had an internal hardware group. And with the internal hardware group, they probably dictated a couple of things to the library and vice versa. So by doing that, there were certain layers that they've kind of allocated as a result of that. And these are the big four that you'll see. So mechanical layer 1 is for board, outline, and notes. Mechanical 6 for top assembly. Mechanical 13 for the 3D bodies. And for mechanical 15, the courtyard. So if you are looking for any type of standard and you want to bring in parts from Altium's content library or download them from Altium, then you may want to consider these for your library. What are our recommendations here? So the biggest thing for is just making sure everyone in your company uses the same layers. It's one thing to demand from all the companies saying, hey, everybody out in the industry, let's come up with a standard. But it's even harder just to get everybody in the same company to just adhere to the standard, especially if they're building their own libraries. So if you're trying to do that the difficult task of trying to say, someday we're going to have a central library, someday I'm going to collect all those parts from all my colleagues and I'm going to put them into one. This is one of the big things that they're going to have to do, is just make sure that all the layers are the same. And that's one of the major roadblocks in doing that type of library collection. Number two, have some scratch layers. So if you have some items that don't warrant a dedicated layer, you can put them on these scratch layers rather than trying to dedicate something very specific for all these different things. And of course, you run out of layers very quickly. You just have these scratch layers available. 3 or 4, actually keep them in even numbers, probably 4 of them or 2. And for the second reason here, keep the top bottom adjacent to each other. So a lot of times with mechanical layers, you have a top layer, and there usually should be a corresponding bottom layer. And even if you don't draw on the bottom layer in the libraries, you can do mechanical pair matching in the PCB. So you can say, hey, look, if whatever gets flipped onto the bottom side and it was on mechanical layer 13, I want it to be on mechanical layer 14 to represent the bottom side. So you want to try to keep those together as much as possible. Again, if you're using an old standard and later on you realize, ooh, we should have put that in there, and you put it to a different layer, is it going to be the end of the world? Absolutely not, right? We know that these things happen. Nobody's got perfect foresight into this. I can't tell you how many mistakes I made, false starts, I'll call it, and trying to get this library all set up and ready to go. So I know it's not an easy thing to set up a library perfectly right from the very start. And then also, one of the recommendations from my colleague was to set up a PCB template. So it's one thing to do it in the library because the libraries are always there, but for a project, those mechanical layers are always going to have to be redone again. Altium does not have a PCB DOT file, which I know a lot of people have been screaming them for, and I too joined that course in that, and I hope that someday they will have it. But until then, the recommendations I would make is that in the DXP preferences under System, New Document Defaults, they have a feature that's called New Document Defaults. And so instead of Altium pulling a template from its template directory for a new file, you can redirect it to another template file. So you can set up your PCB with your mechanical layers, maybe some of your DRC rules, anything else that you want to set up in there, and you can tell Altium, say, look, every time I do a file new PCB, I want you to pull this from this directory, from this file name, and it will basically copy that and make that your default as you're going along with your project design. Or better yet, do it for the entire project. So have a project template also for your .prj PCB if there's any, what do they call them, properties that you need to set specific to the project, or any specific things that you want to set for your schematic. Okay. So just some thoughts that we have over there. So hopefully that gives you kind of a general feel about the mechanical layers at this point. I agree I'd like to see a standard, but I think at this point just not going to happen. Now, let's talk about component naming conventions for a moment. Those people who know me pretty well, is I'm slightly OCD when it comes to organization and office supplies. And I don't know if she did this on purpose or as a mistake, but my dear darling mother sent me a really wonderful audio CD called The Perfect Mess, The Hidden Benefits of Disorder. And it was really actually an excellent CD, and I'm going to take an example from this. They talk about this movie High Fidelity over here. But what The Perfect Mess is talking about is the problem with organization to the point where it's never perfect, especially with naming conventions. So you can get to the point where, yes, you don't want to necessarily live in a chaotic world, but if you spend all your time organizing, you get to a point where the organization takes as much effort than what it's worth, and that's really what they're trying to do. So they give an example here about records or CDs, and the reason I wanted to do this was because I figured this could be related to everybody out in the audience here today. So if you have a large CD collection and you wanted to somehow organize it, you're tired of trying to dig through 300-400 CDs. Okay, I know I'm old-fashioned, but if you're trying to dig through it and you've got them over here, how would you do this? Well, you can sort it by band name, okay, or you can sort it by album title. You can sort it by genre, and in the case that they give over here, they actually sort it by mood. So let's take a little closer at this, at the limitations of doing each one of these, okay? So I wish it was really straightforward. Said, yeah, I'll just do it based on, for example, band name. Well, now you get into some really weird things over here. Like, for example, you got someone like Phil Collins who went solo after he worked with Genesis. So do you try to keep those together, or do you separate those apart? You get someone like Paul McCartney, who of course everybody knows from the Beatles, and he was also with, Wings. There's Wings, and there was one other one before he went solo as well. So again, that even breaks it apart. Same thing with Eric Clapton. How about something like the Star Wars soundtrack? Does that sit by itself under the category of soundtracks, or is it by John Williams, who composed it? So you can see automatically that the band names get kind of difficult. Plus, also band names have changed over time as well. Some of them just revamp their names, or they get together and they change the names. So maybe band names isn't the best way to do it. But what about the title of an album? All right. But the problem with doing that is that now it separates the band's works to the collection. So someone like, well, I just heard recently that Neil Young put out 36 different records, right? Neil Young's been around forever, and it's going to be scattered through 200, 300 CDs. That's going to be tough to find his stuff. And then also you got to know the album name when searching alphabetically, or especially if you're trying to find a song, or if you don't even know the title and how it's related to the artist, you'll have to go through these very specifically in order to do that. So it gets kind of difficult to use that particular method. Hopefully you're seeing, the whole reason for me doing this is that you're hopefully seeing that the components are going to happen the same way. So for example, even with, if you take an LED, for example, an LED, it's really a diode, but do you call it its own category of a diode, or do you call it an LED, or do you call it a transducer? Because a transducer, by definition, is something that takes one type of energy and converts it to another. So what category does that fall under? So you can see that even components get tangled up in this concept as well. For genres, again, you get these blurred lines. How about the Eagles? Are they considered country, classic rock? The Beatles, are they originally started as classic rock and roll, and now, pardon me, rock and roll, and it kind of ended up as classic rock, and so on and so forth. And even mood, if you're one of those people who do things like, well, I remember this was played at my wedding, or this was played at my graduation, or I used to play this song all the time when I was in high school, well, that's specific to you, but how would someone else be able to recognize your system? So that's the point I'm trying to make over here, is that no matter what naming system we try to use, it will never be perfect. So what recommendations can I make for you? The biggest recommendation I can make, and this is, by the way, an example, this is not a perfect example by any means, is that you want to go from broad to specific. Okay? In fact, I learned this very early when I was in Scouts. MREs, right? I learned about MREs. Well, they come from the military. What do they stand for? The M is meal, comma, ready, eat, right? So even the military uses this concept of going from broad to very specific. All right? Now, there's two different setups over here. The first one I'm going to talk about is symbol-centric libraries. And symbol-centric, just to refresh everybody's memories, these are libraries that you create the symbol graphic, and then you provide the intellectual data to it, its parameters to it, and then you connect the models to it. Okay? And that's what we call a symbol-centric library. It's also a traditional library. It's not a database library. But when you do these kind of things, then each one of these representations in your library is very specific to a component. And that's why you see what we've got over here. So here's an example that we set up. Again, doesn't have to be done this way, and you can put it in different orders. This just happened to work a little bit better for us than other methods, where I want to sort this not necessarily by resistor, but I want to have a general category called discrete. So we actually have a discrete category, an IC category, component connector category. And by the way, even with ICs and discretes, when it comes to like operational amplifiers, there's that blurred line again, where is it actually considered an IC, or is it actually considered to be discrete? And I can see arguments for both of them, one based on its package, the other one based on its function. So there you go. There's an example over here, and you can see we go from very specific, probably very broad, and then we simply start moving into more specific over here. And so to the point where we even know what the company name is. So again, is this the perfect example? I think it's got, there's probably other ways we could do it. Is it going to guarantee that I can find things? I'd say the answer is yes, at least the way we set this up over here. All right, when it comes to database libraries, you don't have to put all this rigmarole in here, because unlike the symbol-centric library, where each one of these represents a real component, at least the way we've set this up in our library, over here we want to do design reuse, in particular the graphic. So here's an example of all these different graphic types, and I, at this point, would want to again go from broad to specific, but I would have a general category of diode underscore, and then each one of these types over here. So if I was doing a database library and said, oh, I'm doing another Schottky diode, for example, I can easily find it and use the same one for multiple parts that I may have in my database. So that's the key thing I'm trying to drive home with naming conventions. Go from broad from specific. Whatever one you've got, stick with it, right? And that's the biggest problem I find. It's not necessarily that you didn't do the best way of doing it, if there is even such a best way. It's just that the convention's not being followed consistently, and that's what makes it really hard to search and sort. All right. Naming separators. This is the one that I really got tripped up on when, again, I was working for this one company helping them set their libraries up. Naming separators, these are the things, what do we put between information? Now, in the last examples you saw, I was putting in the underscore, but there's other things that you can put in there as well. They're needed, they're necessary, but we have to be really careful with them because things go outside of Altium, and once they go outside of Altium or our workspace over here, they can have a profound impact further down the road or on different programs. So, for example, for databases or Excel, and even outside databases like PLMs and MRPs, they have to use delimiters. So if things are not consistent, you're going to have some problems getting information in there because they want the delimiter to be consistent throughout. Or if you're using some type of parsing of data. I was a huge fan of awk. That's why I put this over here. It's not really used anymore. It was really superseded by Perl. And there's also Tickle as well. But whatever language you use over here, a lot of times when you're parsing data, you need to have some way of understanding a record separator in it. And again, if there wasn't a consistent way of those separators, it makes it really hard. You have to start creating exceptions in order for it to say, okay, if you see something that looks like this, then you got to count the number of letters, and if it says this, okay, we want this, or if you see this word over here, then this is an exception, look at it this way. And it just adds a lot of extra code to the whole parsing of data. Okay. I call this the attack of the meta-characters. When I worked at Altium Support, there were about 15 instances, and I really wish I could get a hold of that list again. I can't see it anymore. But there were about 15 instances I had written down, or reports that we'd gotten in from the cases, where someone had a problem in the PCB side, not on the schematic or outside of Altium, but on the PCB side because they were using meta-characters either in the libraries or in the netlist. Okay? And so you really want to try to avoid these things. If you understand programmers, the only what I'll call meta-character they ever use in their programming language is the underscore. And the underscore has always been traditionally used on the computer side of things, not on the typing side of things, but on the computer side of things to represent a white space. And it's never really been used for anything else. You can use it for pragmas, but that's a very rare exception. So, but for the most part, the underscore is always, to me, one of the safer ones to use. Okay? So if you look at this example that we have over here, look at all the different things that we added, or all these special meta-characters that were used in here. And by the way, these meta-characters have different meanings. They're shortcuts in certain operating systems. And they're also, for example, in Unix, if I was to just put an exclamation point here and press return, it means repeat the last command. But all of these things have a use in whether it's Unix or in the Microsoft operating system, and that's why you want to be really careful with it. So here's an example of a couple of things, like, for example, the modulus operation in a lot of computer programs use the %. If you have a period that's going to represent a floating number, especially if you're trying to bring in data, is it going to treat it as text? Is it going to treat it as an integer? Is it going to treat it as a floating point? Or is it going to treat it as a float? That's why you got to be careful with the period, for example. Again, it depends on the program and how smart it is to look at something between a character and a command. The division would be a division operator in terms of a naming convention, and the white space is the classic field separator in most OSs. So I have to admit I abuse this now, but I do remember a time 15, 20 years ago that it was real taboo to ever add a white space to a file name or to a directory structure. Now the newer OSs seem to handle it with a lot more grace. So, well, what am I going to say about this? What's the short of it? When it comes to these record separators, you want to keep the meta characters under control, or the separators, you want to call them that. So the fact of the matter is you got to use them. It's just, again, it goes back to the idea of being consistent with them. So the best separator, again, I mentioned the underscore, it's the visible white space. The worst one that I think you could possibly use is the white space, because it really is difficult to understand. Is that a part of this? So maybe it's a word that's got a separation by a space, or is it truly the end of the record? So that's why it's so difficult to understand when the record ends. Commas are the de facto standard, but again, use them carefully. So if you're going to use commas, then make sure that that comma doesn't somehow make it into a number or some other way where it's like, oops, just like the white space, it was supposed to be the record separator, not something to clarify or for grammatical purposes. Let's see, and then of course what I'll call the safer record separator is this thing called the backtick, or the the back apostrophe symbol. It's the one that is just below the escape key. It shares the same key with the tilde. And that one's kind of useful too because it's very rarely used out there for an ASCII character. So in fact, Microsoft Access, I think, purposely uses it because it's a safe delimiter to use. That's what I'm going to say about the naming conventions at that point. Again, the summary of this is, if you got a naming convention, be consistent with it. If you're using Metacharacters, be consistent with those. All right, let's talk about footprint naming conventions in particular. There is a spec, IPC 7351B. You can find this one on the internet. So if you look it up, you will find it. You can download it. You can take a look at those things, and it provides a very good framework for footprint names. So what are our recommendations for the footprint side of things? It's interesting. Feel free to create a generic part for a very specific naming convention, like an 0402, right, and so on and so forth. But if there's something unusual about this part, and this is where good DFM practices come in. So if a company is claiming that they're doing, let's say, an 0402, well, make sure you check very quickly their dimensions to ensure that it actually adheres to an 0402. Because the biggest problem we've seen out there is that companies will claim to follow IPC conventions, at least in the shape of the footprint, but they don't always follow the dimensions of the footprint pads. Okay, so if you want to use this, it's fine. And if there's something very specific to a certain part, then feel free to add something to the end of it. The other method is, and this always does happen too, is someone's come up with a very, very unusual part, is not a part of the IPC standard. At that point in time, you probably want to put the manufacturer's name, underscore part number, underscore details. And this is the example that we're showing over here. Is this the best way to do it? Again, there are certain ones that probably could have been a little bit more generic, and I probably didn't even have to put generic in there. But these are the two recommendations we give when it comes to footprint names. How many footprints? So I've seen some companies have up to 4 footprints. They'll have one that's very specific to the manufacturer's recommendation, along with what the IPC has provided in terms of their traditional M, N, and L concepts. So why did IPC even bother with the M, N, L, which is maximum, nominal, and least, to begin with? Well, there's kind of 2 reasons, or it really has to do with the concept of the solder. So the idea is that you have the meniscus, and when you put this part onto your board and you start heating it up, that solder obviously liquefies at that point in time. And generally speaking, it will do self-centering, okay? And not only do you want it to self-center, you also want to make sure the solder makes itself all the way around so that there's no opportunities for cracks, or there's areas where it could break off, especially if you're doing high rel type of stuff here. So that's what they were trying to do with this over here. If you want to, you could probably reduce this from, let's say, 4 footprints to a nominal where it's based on the IPC standards. Or pardon me, one of the ideas was to do where you'd have the IPC, 3 of them, then you could do the manufacturer's footprint. This is what the IPC is generally recommending, and again, I'm being very vague about this. Or you could say, look, my nominal will be based on the manufacturer's footprint with plus or minus 10%. You could possibly do that as well. But I think the point that we want to make here is, why do you want to build these? Okay, it's kind of good to know that you can have these different size footprints, but that's a lot of effort to have to go shuffling through and having to put those down. In Altium, they give you the footprint wizard, so you can obviously select those things. Probably not the footprint manager, pardon me, in the schematic side, so you could select those things. But the ultimate question is, why are you even bothering with them to begin with? Well, if you're going to do a lot of hand soldering of the components, then yeah, you probably want the max size. And if you're dealing with extremely tight boards, then you probably want to have them in size. But in general, the footprint, and I'll just, if you don't mind me, I'm just going to read it straight off over here. The footprint that is built with the manufacturer's nominal dimensions with general tolerances taken in consideration is perfectly fine. Okay, and that's what we find here too. We here at 9.Connects will generally ever build a library with more than 1 footprint in it. We'll just say, hey, this was work. We took a look at the manufacturer's specifications and we built this to its nominal here, and that should be more than adequate for what's necessary to do. Okay, now we do have a comment to make about this. What we have found more and more is that a lot of people are trying to jam a lot of stuff in very tiny spaces. And the more tighter you try to make things, the more time it's going to take to place it, to route it, to investigate the fabrication assembly limits. Because when you start getting really tight with things, you got to start talking to the fabricators and the assemblers to see who can do that type of work. and also to adhere to it. So it's not just investigating to it, it's also making sure you adhere to those things that they tell you. And ultimately, when it comes to testing boards that are that tight, it's really miserable to do. So our general philosophy here at 9.Connects is pretty plain and simple. Don't levy a requirement that's not required. And if you or your end customer comes back and says, look, we really don't care how big or small the board is. Obviously, we don't want it to be massive, but we don't have a specific requirement that says it's got to be 2 inches and you're trying to put 200 parts on it. If they're not levying that requirement on you, then don't necessarily levy that requirement onto yourself. All right, cram parts only when cramming is required. Because if you were to look at a line I was looking for, I just didn't have time to find one, but there have been people who do studies on this, and what you'd find is an asymptotic line that goes up very quickly, where the density versus the time, the denser things have to come, the more time it's going to take, and it almost gets to the point of no return, where it's so dense it just can't be done. All right, and so don't levy that on yourself if you don't need to. And again, it goes back to the concept of how many footprints do you need? Well, again, if you just do the nominal, most manufacturers will be perfectly content with working with that. Okay, let's get on to Courtyards. I promised this in the last presentation. Let's get on to this one here. Courtyards are not the assembly layer. The assembly layer itself shows a little bit more detail. It also has the reference designator. Courtyards can have the reference designator, but they're really used for other purposes, in which we'll talk about here in just a moment. Here's the IPC definition of a courtyard. It is the smallest rectangular area, which in Altium we call the bounding rectangle, that provides the minimum electrical and minimum mechanical clearances. Right? So what they're saying is just put this thing as tight in as you can. But our issue with this here at 9.Connects is that we find that minimum is a very, very relative term. So let's give you a really good example over here. So by definition, let's take a look at this handle here. If I was doing minimal mechanical and minimal electrical over here, then my bounding rectangle for this courtyard would be just around where this 3D body is. Well, you know what? I don't like scratching my knuckles on components. And so I would actually rather have a bounding rectangle over here that lets people know that I don't want anything in this area here. Okay? So that's why we kind of changed out the definition here. Our definition is a boundary that represents the area necessary to represent any of the functions, such as test, assembly, fabrication, mechanical work, rework, that will be performed on the PCB or on the component. So again, if I want these handles to be on this, because I have a large back plane and this PCB is going to represent that, and I want to be able to grab it here, I want it to be mechanically set up so that I can ergonomically pick this thing up without hitting components or scratching my knuckles on them. All right. The general rule of thumb, courtyards should never overlap, and if they overlap, you're going to be responsible for those ramifications. Understand if they are doing that, hey, understand why you're doing that. If you see a large courtyard in the library and you don't understand why it's there, ask the librarian why it was put there. There was some thought behind it. Okay, what do we use them for? For layout, they're very, very quick visual placement. So you know that if you place these things and you look at nothing more than the courtyards of them, you know that as long as these things aren't overlapping each other, you're going to meet the mechanical requirements. You're going to meet the component clearance requirements. Why do you need to put them on here? Well, sometimes you need egresses for connector clearances. We saw that example with the handle on the last slide here. For assembly, if you're going to do rework, you want to make sure that that area is going to be clear, because a machine like this, you can see this nozzle for the heat that they would be putting on there, has to have enough space, and you don't want to be sitting on capacitors and other things that are also going to break off as well. And the same thing is you don't necessarily want to have to remove all those parts in order to finally get to the part that you're trying to do rework on. So also for pick and place as well. All right, pick and place has gotten a little better. I guess they do a lot of an air gun type of thing where they kind of shoot it on there through a piece of air rather than having a piece of mechanical equipment come down. So it makes things a little bit tighter. But again, if there's using older equipment, you want to make sure that that mechanical equipment can come down when it's placing it on there. And also, obviously, for test and for probing, you want to be able to get that test probe in there. And if it's so tiny that you put that, you put what's basically a baseball bat onto a 2x2 inch tile, you know it's going to move around and it's going to be really difficult to keep on there. So you want to make sure that if there is testing to be done, that the probing can be done very easily. For courtyards, so just some general rule of thumb here, at least something to start off with. The idea behind this is that if you've got a solder mask clearance, you have your silk, right? You generally want to have your silk in there if you're going to use silk. As we mentioned, other DFM webinars, sometimes silk is not the thing to do in production. but in other cases, if you're just doing boards and you want more information, it's perfectly fine to have on there. The idea behind it is that you'd want to leave at least 5 mil clearances minimum, if not more, between your solder mask and your silk. And then, of course, from the silk over to your courtyard, you want to leave another 5 mils. And, of course, if the courtyard's got to be bigger, then so be it. Draw it out larger. And, of course, if it's not larger in the library and you have no control of the library, you can always go into Altium, say, unlock primitives, and you can redraw it out to be larger if necessary as well. So just a general rule of thumb here to at least start off with. All right, let's talk about the thermal. Thermal has been an interesting one. We've actually spent quite a bit of time on this in this library that we're putting together for you guys. Here's an example that will guarantee via and pad unless you want to take your chances and watch all that solder go basically wick down into the hole here. Okay, so this is an example that would require plug vias. Far more expensive to do it that way. In some cases you can't avoid it, but if you can avoid it, then you would like to make it in such a way that you don't have to do that additional expense. Okay. So what are thermal relief? So a lot of times these parts are running hot. The smaller they are and the more current that they're taking, obviously there's a lot of heat. So you want to get that transferred over to some plane, primarily the ground plane, because copper is not only electrically conductive, it's wonderfully thermally conductive as well. But again, you've got the solder issue over here. That solder is going to get pulled down here, and you can do what's called starving the copper. And that is a reliability issue because you could probably, this thing will probably function just fine. You'll never know that there's just not enough copper underneath this until you start getting possibly field failures there. So you're taking a chance by doing something like this and hoping that, yeah, there's enough solder there and we're running it through the system fast enough so that whatever solder remains will be perfectly fine. That's a big chance you're taking. Okay, but let's give you a real example over here. And by the way, I'm not here to beat up on TI on this. We're seeing this on a lot of other companies as well. We just thought it was a very interesting example. So here's one of the parts that we had. And in the part, the recommendation was to put in 6 vias that would go down to ground. And the recommendation that they make over here is that if you keep the holes 10 mils in diameter, that should prevent the solder from wicking through at any great speed. But our concern with this, now I suppose again if you're doing prototypes, you're not doing anything that's going to be out in the field, obviously not for high reliability, this will work out perfectly fine. Will this recommendation work? Well, now you're putting your faith in 3 major factors. One of them is the solder material. How thick is that paste? Okay, is it runny? Is it really thick? Is it somewhere in between? Also the speed of the equipment in which this is going to be flowing through. So is it moving at a certain rate? You also have a temperature issue here as well. Okay, so all 3 of these things are going to play a factor in this. So this recommendation over here, to me, is a little bit scary, especially if you want to have any type of high reliability. Okay, so here's an example. And by the way, the original design doesn't even call for these in here. They're saying if you want to, they want you to put these things in here, and they're giving, well, actually, this one does here. But let me rephrase that. There's a 3rd specification here saying that they recommended more vias as well. And that's kind of what we did over here is we took the best of both worlds, saying, well, they want 6 vias. We don't want to do via and pad. We're a little bit concerned about the recommendation over here. So what we did here was we said, okay, well, let's bring these out on the side here with the specific intention of having solder mask for the rest of this. So the black area is the solder mask. Remember, it's a negative. So this is the area that would be actually exposed, right? So these would be the things that you would actually paste onto. This area over here would be covered under the solder mask. And so by doing this, I get the best of both worlds. I still get my thermal reliefs here, and I know that I'm not going to have to do via and pad, and I'm also not going to have to worry about the solder getting wicked down below this here. So just a recommendation to make. So when you see these type of things, see if there's an alternative to doing this, because again, if you're doing via and pad, it's an expensive alternative. All right, 3D. All I'm going to mention about this, because I think Altium's pounded this into every Altium user at this point, it bridges the ECAD and the MCAD worlds together. It allows for cross-discipline cooperation and obviously fitment as well. So we can't emphasize enough that that 3D capability is something you definitely want to use. Side note that I'll make is that if you don't have time to do this and you don't have an MCAD guy to do it, there is a batch wizard that you can run in the PCB in Altium that will just take it'll show you various bounding rectangles and say, look, we'll draw a gray block over there, so it almost look like a cityscape. It's not going to have anything pretty, but it will give you the length, width, and height which will be necessary for you to actually get some type of fitment done if necessary. So you can take a look at that. I think it's under the Tools menu in the PCB board editor. Let's talk about the etch PCBs, and this is one that we'd like to get some feedback on. I don't have enough time to talk about all of these things, but I think each one of them does have some interesting aspects to it. So etch PCBs are those things that get built in, and hopefully in the future we'll see things like resistors and capacitors and other things in there as well. They're going to have to refine the processes to make those type of things happen over here, obviously, but there is a lot of things that you can definitely etch in there. And again, I don't know if this poll will work or not, but if the poll does pop up, we'd like to know if you'd like to see a webinar on these, and we can spend some specific time on each and every single one of those here. The key thing I want to talk about when it comes to etched components is that if you use mid layers like this example over here, you are committed to those layers. So the minute you place that down in the PCB, those layers will be enabled. Okay, so be very careful about what you're doing over here. So like an example, this one's really cool because it's actually an inductor that was built into the board. However, it's using 3 layers, so the mid layer 1 is going to be turned on automatically. You can't turn it off. Altium's going to complain saying, sorry, you got library components that are using this. Okay. And secondly, and this is something we see primarily with fiducials, and there's some other ones too, or mounting holes, an etched PCB component should have a schematic representation on it. Going back to our last DFM discussions that we had, keep in mind that the schematic tells a whole story, and it's okay to have other things on there other than just schematics, even if they're not a part of the netlist itself. You want to tell the whole story so everybody understands what's going on in there. Plus the fact that if you're familiar with Altium, if you put something on the PCB and it's not on the schematic side, you have to be very careful about the ECO process to make sure Altium doesn't blow it away in the PCB, or B, you've got to go into the PCB options and turn off certain things. And again, it's just kind of a hassle. It's just easier to have it represented on both sides. All right, hardware. Things like our infamous handle over here, and even a right angle bracket, any other type of hardware in there. Hardware should be added to the bill of materials. There's 2 requirements to that. Number 1, it has to be represented as a library component. It can't be represented as free primitives on the schematic, otherwise it just won't show up. So you've got to have a component in the library in order for it to show in the bill of materials. And number 2, you got to add to the design. So if it's not added to the design, it doesn't show up in the bill of materials. And even if there's no netlist association to it, so like these 2 examples that we created here, we didn't actually put any netlist association to it, so we didn't actually make any copper screw points, for machine screws or for any threaded screws on either one of these here. But the fact of the matter is that even if there was no netlist association to it, you still can use the 3D in the PCB. So make sure you don't turn it to what they call mechanicals. There's different settings. You still want to call this a type standard. So yes, it does show up in the bill of materials, and yes, it will show up in the PCB once you do a ECO over to the PCB for the footprints over there, and it will still show up, and you can place them where you need to, and it gives just a wonderful representation. And shoot, if you really need to, if you need things like cleaning solutions or soldering or anything else that's associated with that board in order to kit it, feel free to put it on the schematic, and you can declare it as a mechanical at that point. There may not be a footprint for it, but it will show up in the bill of materials. So feel free to use your bill of materials for whatever you need to do it. Use your library in order to get that information on there. It's okay to put that on the schematic. I know there's purists out there saying, no, it's strictly electrical, but if you want to have a complete bill of materials and you don't want to have to do a lot of manual effort thereafter, I would highly recommend it ends up in the library. And you can always have a specific schematic sheet for those kind of things too, so it's separated from everything else. So that's
Paul,
what I mentioned. Yes.
Let's try to launch this poll, 1-question poll, and
okay.
I'll put it together.
All
Let's
right.
see if it works. There we go. Do you see it?
Yes, I do. All right, let me take a look over here. That's right, I'm the one. So the poll that we're putting out there right now is we're kind of curious to know how many individuals are doing their own CAD work. Are you doing your own library work? Do you have somebody else doing it for you? We're always kind of curious about those type of things because we know we're dealing with designers. We just don't know if you're wearing multiple hats. So that's being opened up here right now.
Yes. So please go ahead and choose your answer, and we will share in the next few seconds what percentage of you have selected either 1, 2, or 3 as their answer. it appears 80+% are choosing number 1.
Sure. Yeah, so that's kind of what we expected, but it confirms what our suspicions were in regards to those, and to all of you out there who have to do these type of things. So hopefully you're finding the information that we're providing over here is useful when you're going through the creation of your parts here.
Thank you very much.
This. Yep. Okay. Let me finish these. I think I have 2 more slides over here to talk about, and I think we'll be able to answer some questions as well, which will be great. I haven't answered questions in a couple of webinars. Talk about symbols. The 2 things I want to talk about symbols. For ICs, when it comes to ICs, you don't have to put everything in numeric order. As we talked about in the last webinar, we'd like to see things go from left to right, but that doesn't mean that the pins necessarily have to be in order of operation. They actually should be grouped so that it's easier to read. And one of the things we recommend, because we see quite often on schematics, people will put the bypass capacitors on another page and they're all listed out there, and you have no clue what those bypass capacitors are associated to. Well, here's a kind of a great way of doing it. So you'll notice over here there's a number of grounds, there's a number of VCCs, there's even an analog ground and an analog VCC over here. And so we configured this in such a way that if we wanted to put bypass capacitors for each one of those, it was very easy to do, and we know exactly which capacitors are associated with this particular IC. And we also see the pin numbers there as well. And so it makes it very, very easy to see those things as a result. So just one recommendation we would make here is putting those on the bottom so that you can get those bypass capacitors on there very easily. The other one that I'm going to mention here is classic digital ICs. The reason I bring this one up over here, because I don't think it's very commonly used anymore, but just in case, certainly in the early 90s and prior to that, and I was part of that as well, when you're using the 5400 series for military, 7400 series for commercial, and you were actually building things based on logic gates, and you had to purchase these parts and you had to tie them together. So it was very common to see a lot of libraries with these type of parts in it. Now a lot of times people just basically throw down the IC block with the pins on it, and that's perfectly fine as well. One of the problems that comes up when you do this style here is that you have power and ground issues. And so what are the ways you can handle this? Well, one of the ways is to hide the net. Please don't do that. I think it's a terrible method. I can't tell you how many times people called Altium when I used to do support saying my board didn't work. I found out there was a hidden net in this thing, and as a result, it didn't get connected together. Okay. And then you just kind of saying, well, you got to be responsible for these things. You got to look at your warnings and messages. So there, we had our standard responses to that thing, but I felt really bad about it. And the fact of the matter is that I just think it's a bad practice. So please don't hide nets. And if you do hide them and you've got 20 sheets, Altium will give you a warning about them. But if it's a hidden net like ground, good luck finding it. It's really hard to find. So I don't recommend hidden nets. The second method is this universal thing. They call it owner zero in Altium, and the idea is if you had owner zero, all of these things would have it, which you could do, but that's kind of, I think it's overbearing at times. The other method I've seen as well is that a lot of people will use, like they'll say E. The section E over here will be specifically set up for power and ground. The problem I got with that is that people forget that one. So they say, well, I just only need 2 of the 4 of these, and then they'll put down A and they'll put down B, and they completely forget to look at E for the power on that. So I have an issue with that one as well. So, and through a lot of discussion with my colleagues at Altium, one of the things that we came up with this methodology over here is that part A actually represents the power, so that means you don't forget it, and that the other ones over here would represent your logic over here. And what's nice about this part A is that this part A actually straddles the rest of this. So by it straddling this, you could put on any one of these over here, and it overlaps. And if you have an analog component, you could do the same idea, but you don't have to straddle it. So like for example, an operational amplifier where you've got a lot of pins coming out of it, and you don't really want to have this over here, but at least you could have it next to it. And you have the option to put it on there if you really want to at that point in time. So this is just some food for thought if you're going to do digital stuff. I think it's becoming kind of archaic at this point, but people still use it. And again, I think that the other method of, and I'll just flip back up to this one, just doing a classic IC in this nature works just as well. So thank you very much for attending, and we hope to have you here next month.